So I'll boot it up and take a look and see if we actually get any overlap checks running here properly. And I forgot to zoom way in, so we're just going to go ahead and do that. Yeah, and our second favorite thing to do besides watch the compile window is to watch the DLL loading window. That's another one that's just really engaging. So trace tag overlap. And you can see we are doing a few. Well, at least we did do a trace. You can barely see them. At least I saw it for a second there. Yeah. Are they just? Yeah, they're like way the hell off of where they should be. Totally out to lunch. So our math is just screwed for these things. So let's go take a look at exactly what is going on. First, let's get our we'll just see exactly what we can do here. So hit the B button. Okay, it is actually going to give us a bit of information here. So we're going to write it down as we go along, because if you don't write down your map, it can get a real pain in the ass. So we are at negative 782.9, and we are at 158.8. So we have 64 frames, and basically there are two collision objects. There's a hit object and a physics object. Does that even matter? Oh, this is on the actual sprite. So we've got the object ident code and the object hash code. So the object type is going to be e.g. hit, which we skip, and e.g. fizz, which we do not. Our check set does not contain the hash of the object, and our position is, it's not giving us our collision object here, but we should be able to go find it. Our size is 151 by 48, which is correct. Our position is 716 by 119. How's your day? Nice to see you, Ishu. It's going well. We're working on checking if we like wanted to play an animation that we're checking to see if we could, like if we wanted to play the stand-up animation, if we were like under a ledge and we were crouching, if we want to be able to see if we can actually play that animation. So we're doing the math right now to verify what's going on with it. So what I'm confused about here is this position is X and Y is totally out to lunch. Like, why is the position 716 by 120? Like, that seems way far away from what we want. So let's take a look at our actual data for what we imported. So this is the air rising stuff for FatSag. So that was air 1, right? Yeah, that's air 1. So we don't care about the pivot, we don't care about the hitbox, we care about the body box. And the X and Y should be like 80 and negative 512 here. Why in the hell would the object position be way off like this? Well, let's take a look at what the differences in the positions would be. If we've got, we're at negative 782. Yeah, that doesn't make any sense. Why the objects would have such a strange position. Because when we set the position here, it was frame data X plus offset frame data object Y. So what I'm guessing is the collision geometry stuff that we have is it's got some sort of offset built into it that's based on the collision geometry is based on the sprite frame on the texture as opposed to something else. So like the offsets and all these things, this position is not the position we want. We want like the frame data MX and Y here, and we just don't have that. That's what it looks like. Let's take a look. We've got, do we have the offset X and offset Y? What is that? Frame data offset X. What the fuck is offset X? So I guess we need a little bit more information than what we have right now. We're actually going to need the we're going to need a little bit more information from these things. Do we have this information anywhere already? Because I don't want to have to go re-import everything. I mean, we can. Over to the left 80, the y minus 512. So where is frame data actually defined here? Dashkin animation frame data is offset X. Offset X is the middle of the frame. So what we're going to want is another position variable here, basically. That is the actual position, which is going to be basically offset X. No, it's going to be frame data X minus offset X, because offset X is the middle of the object. And MX and MY is the corner, I believe, of the X and Y is the bottom left corner of this piece of geometry. So we do need to like re-import all of our crap and add something to our collision object. So the question is this position used anywhere? I don't think it is. So what we can kind of do here is do like F vector, like generation position. There's all of this stuff here. Otherwise, the position is going to be the offset X. It's going to be the vector between MX and offset X. So it's going to be like F vector 2D with yeah, we don't want like the frame width in there or any of that stuff because it doesn't matter. We just want the difference here between these two variables. This is changing editor stuff, so we haven't done this in a little while. So we have the X, the Y, the width, and the height. And that is our object content hash. Object name, object identifier, rect. The width and height, the x. The offset x could change though. I don't think it will, but it could theoretically change. And then it would change what our collision stuff is, so perhaps I should add that in there for this. Because this is just, this is an editor time, basically. We're hashing the string. No suitable from f vector to f vector TB. Well, yeah, that's why we need that. So the frame data offset there. And you do the same thing where we have the generated position and position. So we'll need to re-import all this crap, but I think we will now have like the correct positions that come out of this thing. And basically what our position should be looking like, if we look at this, is it should be our offset x on 0, 0 is 54 and negative 368, so it's going to be like 54, negative 368. So our x and y should be, what, negative 80 and negative 512. So we would expect it would be negative 512 plus 368. So we'd be looking at 144. And negative 80 minus, or yeah, minus 50, 54. So we should be looking at negative 134, 144 for our bottom left-hand corner for both of these things after this. So let's see if I actually did that correctly, or if I just broke the hell out of absolutely everything, which is also a distinct possibility. And I think this is the only place where I'm actually importing. Like, this is our Dashkin sprite utils, update sprite info. I think this is the only spot in the entire thing where we actually edit anything. So why don't we just put a frickin' breakpoint there and make sure we're actually doing it? That might actually be a decent idea. So we're gonna have to disconnect from source control, so we don't take 2 million years to do this. And let's import fatsack. And yeah, it looks like that is the spot where we're doing things. Make sure to save our dude. Let's take a look at fatsack real quick. Our collision data does look correct, so we didn't screw up. We didn't screw up everything. So that's always good. Let's reconnect to source control and close the editor. And then we're gonna do another reconcile and make sure we got all the changes proper. Yeah, we got all the changes. Just put it back up, and we're gonna breakpoint again back into our physics stuff. And it looks like our position was just all sorts of screwed up for our test. So, one step at a time. Sometimes there's smaller steps than others. So here we go. Our collision object, we're going to go through. The first one's a hit object, the second one is not a hit object. So this guy's got a size of 151 by 48. The position is 613 by 368. Well, that's obviously wrong. So let's try to re-import that sec. So what's our position? Our position's being set to our frame data mx. It's not our frame data mx, is it? It's our offset x should always be like that nice variable there that we see, like 58 and all that. So the problem is we're using the wrong x here. We're using frame data mx instead of object frame mx. No, yeah, okay, so we do need to remove a few of these things, yeah. Okay, yeah, let's take those out. And we should be using the object frame mx for these. So let's take a look. We'll see. I still think there's an issue here with this hash for the content hash. We should be taking into account something else. Pretty sure. The object frame X, I think it's more of the well, if the pivot changed, but we'd have to do a little bit more. We'd actually want to check the position here and see if that had changed as opposed to the object frame X, because the object frame X could be the same theoretically if the pivot changed and the collision data X changed as well. So run out, source control, import, bad sec. So let's see, our position is -166, -123. Why is that? Well, we're not going to be, this isn't going to be just Air 1, this is going to be everything. So we're just looking if this makes sense. And that is definitely within the realm of possibility for us. So I think we're importing it at the right position now. So we're going to save everything. Hit that play button, and then let's hit that B button and see what we get. So what are our objects? We've got objects 1 and 2. So what is our position? Our position is 134, 144. That is exactly where we calculated it should be. So okay, we got the right position now. The size also looks correct. So let's take a look here. Our offset position is supposed to be this, and then our object type is a box. So basically we take our size in the X, so it's going to be 151 by 48, so we're going to be wider than we are tall, and half Z, so we made our box, so we got our shape, half extents look good with that, and it is a shape type box. Now rotate our position offset into our position offset, and we're going to take our position, which is 913 by 158. So let's see if they give us the position. They do. So our position now is -144, -779, and then 158. Which is absolutely wrong. Like 144 was our Y position. So this is going to be all sorts of not working. So we're testing the wrong shape. Because our rotation is our get actor transform. Well, let's at least check a few things here. So the shape is... Yeah, so it basically added the Y to the X, and it added the $779 plus 134 is 913. Yeah, so it added the wrong things here, basically. So we added Y to X, and we added the we actually subtracted, we subbed the X from Y. So it's like we rotated the exact wrong way. Like the rotation here should not do this rotation, but like the inverse of that rotation. Its inverse of function. We'll see. Hello, Caracan. We're still messing around with stuff right now. We're trying to get the animated physics. We're right now working on a check to see if we could like stand up, and that means we have to go through all the frames of the standing animation and see if we can actually play those frames in our current location. So we have made a little tweak to Fat Stack and are testing against the world with it. And doing math and all that fun stuff. Did I just undo some of this work? Let's see. The collision objects should be set with the right stuff, which they appear to be. So the position is, again, just writing this all down. We got 873, 158.8. Those are our coordinates set. Ducking and standing up? Yeah, pretty much. Basically, like, can we play this animation in this location? And that whole thing. So this position is negative 144, 739, 158.8. So yeah, that didn't do anything. So why am I rotating this wrong? Position offset is wrong. Everything is wrong. Well, let's just take a look here at what our character actually has. Right now we are 90 degrees in the yaw is our rotation. So let me just build a little rotator real quick. Like, let's just do the F quad. Let's just do F rotator. Rotator equals, let's just say, it's like yaw pitch roll, so is it yaw pitch roll in the constructor? We don't have to guess, we can actually just look. It's pitch yaw roll, so it's going to be 0, 90.0 F, 0. And what we're going to do is just do like pause offset equals rotator dot rotate vector pause offset. Let's just print it out. After rotating in the 90, rotating 90 yaw, the position offset is and we'll do like before rotation, the position offset is after, what is this? I think we want the rotation for, we want the parents transform, like that's the rotation for that. Do we need to like get the rotator from it or some crap? Because I'm confused as to why the like rotate didn't work there. Maybe there's something better where you can do like local to world on an actor. Get the local to world transform of the root component. It's actor to world. Maybe that's what we need. It's like the F transform that we want here is like we want to get. Are we using this transform for anything? No. So maybe we don't want that. We want like actor to world for this transform, and then we can get this rotator here. So it'd be like rotation, rotate, vector, position offset, and then we're gonna do like after actor to world rotation. The position offset is such. Maybe I just had the wrong matrix in there. Yeah, everything's always busted. Shit. We live in a broken world. Well, if we live in a broken world here, it's because I broke it. I'm sorry. I wrote all this crap. I didn't write Unreal, but I wrote everything else. I swear Adam didn't write any of the code, so we can't blame him, right? I mean, we can, but we can't really legitimately blame him. Alright, so we'll roll down here. So after the rotate, if we do the rotator with 90 yaw, this thing is in the wrong frickin' direction. If we rotate 90 yaw, it's not correct. $144, $133. $144, yeah, I just swapped the frickin' axes and all that crap. Well, what I need to do actually right here is we need to preserve the effector to rotate equals the position offset. So we're gonna do like this. So obviously it's not the yaw, it's the roll or whatever. You could try. Yeah, I guess Adam had a real frustrating day then if he was like losing some work and then he's playing Hollow Knight and he's getting all pissed off at Hollow Knight. Just nothing pleases that guy. He's just having a rough week. Cause he had to do all the Bob's Burgers work and then all the other stuff. It's just constantly vexed person. At least this week. Alright, so after that, yeah, so obviously this was the wrong rotation vector, and this one was also the wrong rotation vector because it's, again, negative 134, 144. And that's not what we need. So what am I just doing this wrong? I mean, I must be just doing this wrong. It says the yaw is negative 90. And if you can see that there's this little tiny box appearing, and it's rotated wrong for the tests. It looks like it's rotated into the screen, like it should be rotated. It's being rotated this direction instead of like being rotated in the direction that it should be, which is like that. So it's just the wrong frickin' direction. After the inverse actor to world rotation. You never know what else went wrong. Ah, that's true. So let's see what we got with these numbers. Math, man, what the frickin' hell. Alright, so before rotation, the offset is this. This is if we do 90 90 yaw. No, 90 roll. That's the wrong axis. So what we're looking for is the inverse is not working out here. This should basically be it's just not rotating it right no matter what. Basically these values should be swapped. The y-axis is actually x. So like this 134 should be ending up over here, which so the 134 is working here, but this y value needs to be going to the z-axis. It should not be going to the x-axis. So is it? I guess we can just try the pitch. So its actor to world is almost correct, but we've got the wrong stuff in there. Now I could just transpose the frickin' things, and the other thing is I should actually look a little bit closer here to this offset position. Like I'm saying position X and position Y here. I mean, we could just be saying position Z and just be like, to hell with it. I don't really give a damn. But we're gonna do a little bit more math just because we can. I don't know if we should though. It may also be that inside of our paper flipbook, they're also screwing around with math. So we may be correct in our math, but the math has been changed behind our backs on us. So what we thought was up is down, and what we thought was left was right. And that's just how it goes. Yeah, it looks like some of these axes have been flipped on us, is what it looks like to me. Because we got our 134 over into our z-axis now when we did that for that. So I think basically what we can do is, I think we just set our z pause offset right here to our position x, and it's just basically like our z's are swapped with these things. Because what we should be doing is, this should be a 90. It should put us in the right spot. So YZ. So some swap value somewhere. Yeah, and we're dealing with paper 2D on the back end for stuff. So if like paper 2D swaps some stuff in the background on us, we need to match that because they're using that for graphics. So we want our physics to match our graphics. So if they swap something on us, we need to swap as well. Is it totally freaking swapped on us? Well, let's take a look. What is our? It's at 90. So this is. So we do have the right rotator, and that rotator is. So, after the inverse, so our rotation with the yaw is basically saying this 144. So what are we actually saying? This yaw should. So we should actually have the. This is our left and right, and this is our up and down. This is going to the right axis, this is going to the wrong axis. This is our left and right. This should just be going straight across. This is just wrong.
These companies look to get bigger solely because they're run by business people, not creative people. They don't give a damn about the creative umbrella that's even business people. So they feel personally no attachment to the art that's underneath them. Records and music, as somebody would treat Brillo pads or Frito-Lay's chips. These companies look to get bigger solely because they're run by business people and not creative people. They don't give a damn about the creative umbrella that's these are business people. So they feel personally no attachment to the art that's underneath them. Records and music, as somebody would treat Brillo pads or Frito-Lay's chips.
Do we need to take the inverse of... We shouldn't. We should just be doing the world to actor. Like, we should just be able to transform this thing, to be honest. I mean, it should just be this. Like, it really should. So something must be wrong for us to be doing something wrong with this. Well, let's take a quick look at the paper sprite. Oh, I opened up paper sprite. This one, this file. Don't need paper flip. Paper axis X. What is paper axis X? Source point .x. Yeah, they're doing a whole bunch of random shit, aren't they? Convert world space delta to texture space. So we can actually convert pivot space to texture space. Convert texture space to world space. Well, maybe that's kind of what we need to do. I mean, that's actually what we want, is this texture space to world space for the source point. Source point being the position of this thing. And we have texture space. Oh, do we have texture space, or do we have... It's not a UV coordinate. I think it might actually be this function. So I'll re-import them, and we'll see if this actually does do it. Might work. And if they've already got all the math done for us, we might as well use it, right? So before rotation, the position offset is -4, 0, -26. After rotating 90 yaw, it's this. After actor to world rotation, the position offset is -4, -26. That looks like what it's supposed to be honest. That looks right. That's in the right axes. It shouldn't be. It might be swapped with some of it, but no, it should actually be pretty far down and a little bit to the left. So let's turn on our trace tag overlap. And you can see our overlap is, it's on our guy, but it's not correct completely.